Hello everyone. Today, we will talk about foundation design. So what is the portion of a foundation in your project? A foundation located on the bottom of ground and support whole building load as the structural element. The foundation engineering is able to decide the size of foundation. This decision is basically from earth condition and building load. So today we discuss about what is how we design a foundation, and then what is about the construction process to design a foundation and footing, and then what kind of material you might consider for your design, and then how we can connect foundation and your building, and then what is the major consideration to design a foundation. So let's talk about the foundation requirement first. So what is foundation requirement? To know about the foundation, we have to know how we consider about the foundation for your design. So structure frame connect to the ground foundation and it transfer load from the structure to the ground. The overall load is basically from the dead load, live load, the wind load. So when you see this building, you can see the building weight here, and then you see the foundation in this location. So where is the foundation located from this image? Foundation always locating between the building and the earth. So means the foundation is transferring point between the building load and the earth. So that's why it is kind of transferring moment. So means the foundation has to consider about the load, the building load, live load, and wind load. Everyone know about the dead load, like a building weight itself. What about the live load? Live load always change. It's like a people, snow, the rain, right? So can be the live load. What about the wind load? Everyone learning about the lateral forces. It's more about the horizontal movement. The wind load and earthquake, it has to be considered for the foundation design as well. So what about the principal criteria for the foundation requirement? First, it has to keep maintaining the stability. If it has a limited foundation, building will collapse under the weight of dead and live load of the building. It means it needs foundation having the proper thickness to support the building. So consider about if the foundation is very weak, it's hard to support the building weight. It can be collapse the building, right? What about the next consideration? What is about the next principal criteria? We have to be considered about the limiting settlement. It is relating to the earth. If earth is not enough to support the building itself, the building can stand up even it has the good foundation design. So that's why when you design the foundation, when you're designing the footing design, you have to be considered about actual earth condition. So we talk about this earth condition later today. So when you just consider about earth, when you design the foundation, you have to be control settlement. So we talk about the settlement is related to the earth. If earth is complete and is solid enough to support your building weight, there is no settlement. It's very stable. But your whole site has weak, so means whole building actually sunken, right? Because about this whole site is kind of weak earth condition. So means it disrupts the building service entrance or site element at the building site and interface. So for example, every building is the sunken. So it means it looks okay because it's still standing up. However, if entrance designing here, but building is kind of pushing down, so it means it is kind of a changed entrance point, right? It has a big problem for the accessibility and then for the egress. And then next one, differential settlement. What is about the differential settlement? it causes distortion on each segment of structure members. Therefore, it can cause severe structural damage. So you can see this site. Each point has the different earth condition. That part is complete, but this part is very weak. So that's why the building, the structure member is distorted. It effect damage to the finish, the cladding, and other component where building becomes distorted. So that's why we should consider about the earth condition to design the foundation because about this uniform settlement and differential settlement issue. Okay, so I just kind of bring the video shows some building collapse in Philippines. This accident is caused by failed foundation construction. In this lecture, we look at the proper foundation design and construction method to avoid building collapse. So let's watch this video first, and then we talk about the earth condition and earth material.
Manila, Philippines. Panicked families run for their lives. Their high-rise apartment building is beginning to tilt. An urgent evacuation is underway when suddenly men, women, and children are still running for safety when the foundation gives way. The building rips through power lines, threatening to ignite the entire neighborhood. The tower finally comes down in a massive pile of pulverized concrete and steel. Hundreds are now homeless. Their possessions gone forever. Yet amazingly, no one is killed or even injured. Shoddy construction is blamed for the disaster. Criminal charges are filed against the building's owner. He's lucky they don't include murder.
So watch this one. You guys know about how your foundation importantly works for your building standing up, right? So today we just learning about the basic concept to design the foundation and how you can design a proper foundation design for your design building. Okay, so first one, to design the foundation and to know about the building location, we have to be understanding about the earth material. To find stable soil and earth, we have to consider earth material depend on the particle size, moisture content, presence of organic content. Okay, so let's look at the particle size first. And how you know, before we talk about the particle size, we have to know how you can getting the information about the soil. So we have to do the soil test before starting the designing the building, right? So how you can do the soil test? So usually architect, right, work with a geotech engineer and civil structure engineer to know about your earth condition. First one, geotech engineer analyze the earth condition and they research the earth condition. But you have to remember, the geotech engineer hired by client. Okay, so it's not hired by architect. You have to remember, this is really important because about the responsibility. The geotech information is really important to designing of the building. If geotech engineer provide wrong information, the whole building going too long, right? It's kind of whole building has turned some dangerous later. So that's why as architect, we have to avoid this responsibility. If we hire geotech engineer, all responsibility to us. So that's why as architect, we ask client can hire geotech engineer. And then the relationship between the geotech engineer and client directly, not architect and geotech engineering. So this is kind of more about the business factors, but I think this is really important to know for your future business. Okay. Anyway, the client hired geotech engineer, and geotech engineer performed a research the earth, which is a soil test. Now they give me the soil test, and then they provide this result to the civil and structural engineer. Now when the civil and structural engineer using this data to making out their own proper design, which is structural design and civil design. So they can provide proper thickness of the foundation and the proper structure type basically from the geotech engineering data. Okay, and then civil engineering and structural engineering provide this data to the architect, and then we just using this data to designing our space. Okay, so this is kind of more about the process. Soil test, we always work with a geotech engineering, civil structural engineer, and architect, and the geotech engineer, the hired by client, and then the civil structural engineer, just getting the information from the geotech engineer data, and then they designing about the structure, they designing about the civil part, and then they provide this information to the architect, and the architect designing our building basically from their data. Okay. How we can do the soil test, how geotech engineer performed the soil test. So they usually do the soil boring test. To know the earth material, we need to do the soil test. How can you get in the soil information? You can get in the soil information by boring test. So what is boring test? Simply just getting the earth sample from the earth. Okay. So this is kind of you can see the better process, soil boring test. The soil boring test is performed by geotech engineer by drilling the hole into the soil. After getting the sample from the underground, engineers provide a soil sample for the geotech report. So you can see they just using the drill and then drilling the hole and getting the sample. If you have a site here, this is your site, and then they usually getting the invisible grid line. Okay, and then they choose the proper some location to getting the soil sample. It's not only single point, they getting the few sample to understanding about the site condition. After getting the sample, so you can see that this is a sample. So this is the top soil to the bottom soil. Okay, you can just kind of understanding about what kind of the soil, the composite of this earth. Okay, so from this sample, they making the geotech report. So architect and engineer are available to design and construct the project by recommendation from this report. So when you see this report, you can just find out the depths. You can see the 0 to the -30, and you can also find out the soil type, and also geotech engineer sometimes giving a comment. So you can simply understanding about what kind of earth composite the soil for your site. Okay, so you can simply understanding about the depths and the earth condition basically from this report. So when you're actually getting the information, so you can see this table here, which is a soil type and the properties. This is basically from this report here. So you can just kind of find out a few important category to understanding about the soil type. So you see the soil description, but first one mention about value as a foundation material and frost action and drainage. So just to find out some competent soil, you usually find out this category, which is highlighted category here. So value as the foundation material is always excellent and good and good. It's usually find out from the gravel, okay, and some sand, because it is very good drainage. So usually gravel and sand describe the good drainage, the earth particle, and then it has known frost action. So what is about the frost action? The ground freezes to the depths of several feet during the winter in most part of northern U.S. It increases the volume when water changes to the ice. So means the gravel, sand is good drainage, so means easy to getting out of the water. So that's why it's kind of much less the frost action. However, when you see the silt and clay, they usually contain the water. It's hard to getting out of the water. So that's why the water always containing in the between the particle. So I mean during the winter time, this water moisture expanding the volume because of it change the ice. So it means it affect the foundation. So that's why so you have to be choosing the proper earth for your foundation. Your foundation have to be designing over the good value as the foundation material as shown under this table. Okay. So just kind of basically from the previous table, we have to be discussed about how we can classify the earth material. There's two different earth material: the coarse grained soil, fine grained soil. Coarse soil, basically grave and sand. Fine soil, basically from silt and clay. The coarse, as you know, is pretty draining because about the grave and sand. It's pretty big particle. So means it usually having the very big gap between the particle. So that's why it's easy to getting out of the water from this layer. So that's why it is kind of a good draining layer. Also, it has the big friction between the particle. So means its strength depending on the friction interacting each other. So that's why coarse grained soil is good for the foundation design. Okay, but fine grained soil, which is a silt and clay, but it's less free draining compared to the coarse grained soil. Because its particle is small, it tends to contain the water. So it means water can change the volume because of the frost action. So also more sensitive to the moisture. So it means we always consider about we get rid of the water as much as possible from our side, but the silt and clay usually contain the moisture, so it affects the foundation design. So that's why we have to be considered for your foundation design over the grained soil rather than fine grained soil. Okay. So I recommend using the coarse soil around the foundation. So we'll talk about this one later, right? So also the soil for the foundation, also indicating from the IBC, you can just kind of find out some actual the data information. The bedrock, you can see the allowable foundation pressure, which is a VSF, and then you can see the clay. So just simply understanding about the bedrock is much stronger than the clay. It's much more support to the building compared to the clay. Okay. Also, you can just find out from this table, the coarse grained soil, less sensitive to the moisture content, are more stable. Okay, simply you're just getting the information from here. Also, you have to be understanding about what about the organic soil. Organic soil, also we can call pit or topsoil. Topsoil is the upper outermost layer of the soil, usually the top 2 inches to the 8 inches. Okay, it is fine grained silt and clay organic soil. So topsoil is great for the planting because they have a lot of moisture and then nutrition. So that's, but however, it's very bad for the foundation design because the topsoil is very weak, unstable. It is not suited for the supporting the building foundation. So when you design the foundation, you have to excavating and find the grave and stone layer. So it means you cannot build the foundation over the organic soil. Okay.